Welcome to the Allen Mentoring Every Question Revealed in the SAT College Board Blue Book. So if this is your first time in the stream, or if you're watching this video after the fact, welcome, and check out the channel videos for all of the rest of the tests. So we are on practice test number 4 today. My voice is a little strange. Hope I'm not getting sick or anything. And yeah, so if you want to check out practice tests 1 through 3, we have all of those in the archives. And now we will be going over practice test 4 and section 3, which is the math test, no calculator. So at the moment, I'm only going through the math sections for the College Board Blue Book. If you are interested in other subjects, please let me know in the comments. Or if you're interested in any other tests, so that could be the ACT, or if you're in New York and you're studying for the Regents, something like that. Just let me know, and if I have any expertise on the matter, I can comment and or make another video. So yeah, that's about it for now. Just a note that if you subscribe, I will be doing surprise subscriber sessions. So that means a random day, random time. We'll not be announcing it on the official schedule. And if you're a subscriber, you'll get an email, you'll get a notification, then you can log on and pretty much ask me any question you want in that live session. So that will be for subs only. But other than that, I think I'm ready to go. Today we'll be covering section 3, and I will be just doing this no calculator portion. If there's any time at the end, I'll stick around for questions. But let's jump right into it. All right. So question 1, let's just make sure the old pen is working. Okay, good. Which of the following expressions is equal to 0 for some value of x? Okay, and I see that this is an absolute value symbol, and there's -1, +1. So just for fun, I'm going to plug in 0, right? You can plug in any number you want, but I'm going to plug in 0 because I kind of see that the -1s and the +1s will cancel out. Oh, Alexandra in the chat, calculator free. Yes, I actually really like the no calculator portions as well. Really test your skills. So yeah, I'm going to plug in 0, and let's start with A here. So the absolute value of 0 minus 1 minus 1. And so 0 minus 1 we know is -1. And the absolute value of -1 is +1. And +1 minus 1 is equal to 0. So what do you know? A appears to be the right answer in this case. Now, if I was taking the real exam, and I recommend this to all of you, just quickly scan over the rest of these, right? Maybe you went too quickly, right? You don't want to actually do every single one of the B, C, and D's, but just look over them and see if maybe something jumps out at you. But I'm pretty confident with my answer here, so I'm going to move on to number 2. In the function above, b is a constant. If f of 6 is equal to 7, what is the value of f of -2? So this is a popular type of problem, and I'm actually kind of surprised to see it this early. It's usually, I would say, a semi-intermediate level problem. But what you notice is that you have an x and a b, right? So you have two mystery variables, or as they say, b is a constant, but we don't know what it is, right? So there's two mysteries here. How they help you is, first, they let you reveal what that mystery is, right? So that you could actually find out what b is using this right here. And once you know what b is, then you can plug in f of -2 for x. Okay, so it's kind of a two-step process. So let's see, step 1, f of 6 is equal to 7. So what does that mean? F of 6. So since x is the variable in this function, every time you see an x, I want you to replace it with a 6. So we're going to write this out. So f of 6 is equal to 3/2 times 6 plus b. And this is actually equal to 7. Okay, and I know my 6's and b's look very, very similar, but this is a 6 and this is a b. So what are we going to do? Well, what's 3/2 times 6? 3/2 times 6 is 9. Okay, plus b is equal to 7. All right, and if we subtract 9 on both sides, because we want to do the opposite on both sides, we'll see that b, okay, I'm going to cross this out, is equal to -2. So how does that help us? Well, now we know that I can rewrite this function as f of x is equal to 3/2 x minus 2, right? I'm substituting -2 for b. And now that we've done this, all we have to do to figure out what f of -2 is just plug it in for x, right? Anytime we see something in these parentheses, all we have to do is replace it with the variable in the parentheses. Okay, so I'm just going to replace 3/2. I'm just going to replace -2 with x here and figure this out. So what's -2 times 3/2? So -2 and +2 cancel out, and so it's -1 times 3, which is -3, minus 2 more, and you lost 3, you lost 2 more, you lost 5 in total. Okay, so I hope you stuck with me here. This is a very popular type of problem. You'll see this on, I would say, maybe 60% of SATs. Kind of pulled that number out of nowhere, but I've seen it on a lot. So do not be surprised, and you should be happy actually next time you see it, because you'll know exactly how to solve it. All right. So number 3, x over y is equal to 6. 4 times y plus 1 is equal to x. Okay, if xy is the solution to the system of equations above, what is the value of y? Okay, so how are we going to solve this? Well, as we've discussed in the past 3 practice tests, there are pretty much 2 ways to solve system of equations, either substitution or elimination. In this case, I see to be pretty hard to eliminate. Like they're pretty different equations, so it seems to me that substitution might be the smartest bet. So how could I use substitution here to solve this? Well, I see in this case we have x is equal to 4 times y plus 1. Okay, maybe I should circle x here. And we see that we have another x right here, right? So if this x is equal to 4 times y plus 1, so is this x. So that's how we can actually substitute this for this, okay? And so if I rewrite this, I get 4y plus 1 over y is equal to 6. Did you see how I substituted this right here? Okay, and if you have been following along with me, you know that the best way to get rid of a denominator is to multiply it on both sides. So we're going to multiply y here, multiply y here, and this y cancel out. And so now we get 4y plus 1 is equal to 6y. Okay, so now it's a pretty simple algebra problem. Let's get rid of these parentheses. And to do that, we will distribute the 4 to both of these. So we get 4y plus 4 is equal to 6y. And now we want to consolidate all of the y's on the right side. So we're going to subtract 4y on both sides. Okay, the opposite to both sides. This cancels out, and so now we get 4 is equal to 2y, hence y is equal to 2. Now I realized something. I'm like, why does my head feel so naked? That's because I don't have my headphones. I always have my headphones. Okay, so let me go and grab those headphones. I'll be back in 1 second. There we go. Okay, now I feel a little better. Where were we? Okay, number 4. If f of x is equal to -2x plus 5, what is f of -3x equal to? Ooh, I like this one a lot. So it might be confusing if you've done problems like, let's say number 2 here, where you're trying to replace x with another thing that contains x, right? And that kind of freaks students out, but don't freak out, okay? Just trust the process and follow along exactly how you've been doing function problems your entire scholastic career. So again, if x is the variable inside the function, all you have to do is replace that variable with whatever they're asking you in their parentheses in this new function. Okay? So if they're telling us replace x with negative 3x, that's all we have to do. Okay, so if I rewrite this, so I have negative 2x here plus 5. All they're saying is please replace this x with whatever's inside this parentheses. That's it. So if I was to do that, exactly as I just said, it would be negative 2 times negative 3x. Okay, you see I replaced x with negative 3x plus 5. That's all. And so now if I multiply negative 2 times negative 3, I get positive 6x plus 5. All right, and so bam. So do not freak out if you see there's an x putting into another function that already has x. Just trust the process, substitute it normally, and I promise you will get to the right answer. Okay, number 5. Which of the following is equivalent to the expression above? Okay, so we have a constant times a binomial times another binomial. And whenever we've seen two binomials like these multiplying each other, we know that we usually have to FOIL, right? FOIL. Now, do you have to actually FOIL the entire function? Usually not always, right? Because we see that here, for example, first times first would be 8x squared. Okay, and then if we have to multiply that by 3 again, we would see we have 24x squared, right? So we automatically know that A and D are out because we need to have a 24x squared here. But which one of these is the answer? So we could do it 2 ways. We could either actually FOIL everything and multiply everything, and I think I will do that just to show it to you. And later, after we're done with that, I'll show you the kind of quicker method. Okay, so let's kind of start over again. Okay, so all I'm doing is I want to FOIL 2x plus 1 times 4x plus 1. Okay, and so what does FOIL mean? F, it means first times first. So 2x times 4x is 8x squared. O means outer. So it's 2x times the outer, right? These are the two outer terms. So 2x times 1 is 2x plus 2x. Now I means inner, so that's 1 times 4x. And last means the two last terms. So that's, what did I do there? So that's 1 times 1. So that's last. Okay? But now you might be asking, wait a minute, Alan, what about this 3 right here? This 3 in front. You're right, that 3 is still there. Okay, so that 3 is still multiplying by everything. Okay? And so we see the middle term here. We can combine these two. 2x plus 4x is 6x. So if I rewrite everything, I get 8x squared plus. Okay, and now we can clearly see that once you distribute the 3 to each of these terms, your result will be C, 24x squared plus 18x plus 3. Not too shabby. All right, they're about to get a little harder. Okay, if A minus B over B is 3/7, which of the following must also be true? A over B is in blah, 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 blah. Okay. So it's tough sometimes if you haven't done a lot of these problems to see what is my first step here? Do I separate this fraction? Do I cross multiply? Like, you know, there are a few different ways you can change up fractions and variables. And to be honest, I don't have a quick answer for that. It comes with experience doing a lot of these problems and also seeing what the answers are. Like, you can kind of feel what the SAT test writers are kind of pushing you toward. And I see here that cross multiplying would probably not be the best answer, right? Because they're still kind of in fraction form here. I see A over B, A over B. Okay, so what I might try to do first is just try to separate this fraction here by dividing each of these terms by b. Okay, so if I have a minus b over b, how would I separate these? Well, if you have a single denominator and multiple things in the numerator, you can actually separate them by dividing each of them by the denominator. Okay, so these two are equal right here. Okay, and so if this is the case, b over b is equal to 1, right? So I can rewrite this as a over b minus 1 is equal to 3/7. Okay, and so now I'm starting to see it. So I don't see this as an answer choice, but I see that a over b is isolated here. So maybe what they want us to do is add 1 to both sides. Okay, and this cancels out. So you get a over b. And what's 3/7 plus 1? Well, I can say that 3/7 plus 7 over 7, right? Because 1 is equal to 7/7. So 3/7 plus 7/7 is 10/7. So B is our correct answer. And don't worry if you didn't see the step-by-step in your head before you started the problem. I've done hundreds and hundreds of SAT problems, right? So it kind of comes a little bit more naturally. But if you isolate some of these fraction problems, you'll start to see, okay, maybe I should cross multiply here. Maybe I should separate the fraction. It really only comes with experience. So don't worry. I was right where you are when it was kind of like, what do I do? But we'll get better, stronger, faster. On to number 7. While preparing to run a marathon, Amelia created a training schedule in which the distance of her longest run every week increased by a constant amount. If Amelia's training schedule requires that her longest run in week 4 is a distance of 8 miles and her longest run in week 16 is a distance of 26 miles, which of the following best describes how the distance Amelia runs changes between week 4 and 6 of her training schedule? Okay. So this is kind of like a slope problem, right? Because if you were to draw, these are the weeks, and this is the distance, okay? At week 4, she's run like 8 miles, right? So this could be 4, this could be 8, okay? And then at 16, I'm really bad at drawing, but I guess I didn't have to tell you that. At 16, it's at, 26, and that's there. And so we're basically trying to find what is the rate of change between 4 and 16 here. So how would you find the slope of this line, right? Or how do you find out any rate of change problems? What you want to do is you want to do the difference of the y's over the difference of the x's. Okay, and so we see that what's on the y axis here? We have the distance. Okay, so here we have 26 minus 8. And how many weeks did this take? Well, it was on week 16 at the end, and it started at week 4. So if we do this correctly, 26 minus 8 is 18 over 16 minus 4 is 12. So which one of these is equal to 18/12? Let's maybe simplify this. I can divide both of these by 6 over 6, and that gets me 3/2. And I know 3/2 is equal to 1.5. Okay, so each week she increases by 1.5 miles. You could have also done this manually, right? You know it's 12 weeks, so you could have been like, okay, 1.5 times 12 is 18. Okay, 8 plus 18 is 26. So you could have done guess and check here as well. It's up to you. And if you know me, you know that I do not judge guess and check on the SATs because your goal is to get the highest score possible. So if guess and check gets you through the problem quickly and accurately, that is a very fair, legitimate strategy. And we will be actually probably doing some guess and check later in this test. So number 8, which of the following equations represents a line that is parallel to y equals negative 3x plus 4? So how do you know if two lines are parallel? Well, parallel lines have the same exact slope. And if I was to draw the equation for a line, y equals mx plus b, kind of looks like this right here, the slope is b. Okay, that is the slope. So we're basically looking for a line that has a slope of -3, because if the slopes are the same, then those two lines are parallel. So which of these has a slope of -3? So to do that, we have to make sure that the y is on one side. Okay, the y has to be on one side and everything else has to be on the other side. That's the only way that we can verify what the slope is. So I see in this first problem, the y and the x are on the same side. So if I rewrite this here, I want to get this x away. I want to get it to the other side. So I'd subtract 6x on both sides. Okay, the opposite to both sides. So now we have 2y is equal to -6x plus 15. And now, again, to make it look like this equation, I have to have a single y. Okay, not 2y, not 3y, not 1/2 y, just positive 1y, just a single y. So to get that, I would divide both sides by 2, okay, because it's 2y, so I want to do the opposite. And if I do this, I see that I get here -3x plus 15 over 2. Okay, so similar to how I broke these up like this, okay, I do the same here. I broke this up individually, -6x divided by 2 and 15 divided by 2. And now I clearly see that the slope of A is actually equal to -3. So in a way, we got pretty lucky, but as you do more of these, you can maybe look and scan and see which one it's, actually possible that it's equal to -3. Like for example, in B, if I was to get the y on the other side, plus y, I would see that y is equal to +3x here. So I can quickly do that in my head and not have to actually go through this work for A, B, C, and D. Okay, but at first you might have to kind of get your practice in. So number 9, if A is equal to 2, what is the solution set of the equation above? Okay, so here is maybe a perfect opportunity to use guess and check, right? Because they're actually just giving us a value. Okay, so I can replace A with 2 equals x minus 1. Right? So I mean, I can solve this algebraically, but why would I? There's not that many solutions to check, right? So I see 3 and 6 come up pretty often, so let's try 3. Does 3 work? Square root of 3 minus 1 is equal to 3 minus 4. Okay, so here, 3 minus 2. So the square root of 1, is that equal to -1? Actually, yes it is, right? The square root of 1 is equal to positive and -1. They both work. So 3 does work. So I could take this off and this off. Okay, and so now I'll have to check is 6. Does 6 work? 6 minus 2 is equal to 6 minus 4. So is the square root of 4 equal to 2? And that is correct. The square root of 4 is equal to 2. So now I would pick A as my answer. Now, to be honest, now that I look at this, again, just taking a second gander at it, I've not seen the answer for for this test, but now that I look at it, the square root of 1, is that equal to -1? So in one way it kind of is, right? Because a square root has both a positive and negative solution, right? So the square root of 4 is equal to 2 and -2 in theory. However, the normal convention is that if you write a number under the square root symbol, that you're implying that the solution is only positive. It's a weird convention. I've seen it before. So I would actually have to check the answers for this. I'm going to update this video. I actually now might be leaning toward it only being 6, right, because of this rule right here. So I want you to check your answer key. I have not checked it yet, but I will maybe update this in tomorrow with the actual answer, right? But this little weird convention is something that pops up from time to time, so it might be wise for you to look into it. So number 10, if t plus 5 over t minus 5 is equal to 10, what is the value of t? Okay, so we've dealt with these problems before. They're not intimidating to us because we know to get rid of denominators, all we have to do is multiply both sides by the denominator. Okay, that's all we're doing. Multiplying both sides by the denominator so that we can cross this out. It's a very fun, fair strategy. So now on the left side we have t plus 5 is equal to 10 times t minus 5. So maybe we can distribute the 10 right away here. So 10t minus 50. And now all we have to do is solve for t. So I'm going to subtract t on both sides. Get this guy out of here. And I will add 50 to both sides. Okay. And so now 10t minus t is 9t. And 5 plus 50 is 55. So to isolate t, I will divide by 9 on both sides. I'm doing the opposite to both sides. Right? I'm multiplying 9. What's the opposite of multiplying 9? Dividing 9 on both sides. And so which of these is equal to 50? Oh, maybe 55 over 9 is equal to 55 over 9. Alrighty then. Number 11. How many ordered pairs satisfy the system of equations shown above? 0, 1, 2, or infinitely many? Okay. So how are we to do this problem? So they're actually, all they're asking us is how many solutions are there, right? How many solutions? They're not saying what is it, just how many. And so the way that we want to find out how many solutions there are, if I expand right here on the bottom, y is equal to 2x minus 3x plus 9. Okay. I'm going to FOIL. Actually, maybe I'll substitute first and then I'll FOIL. Okay, so I'm going to write the first equation here. Okay, I'm going to subtract 5 on both sides. Okay, bam, x minus 5, oops, is equal to 2y. And then I'm going to divide both sides by 2 to isolate y. So y is equal to that right there. Okay, so now I'm going to take that and plug it in for this y here, right? I'm substituting. So x minus 5 is equal, or sorry, x minus 5 over 2 is equal to 2x minus 3 times x minus plus 9. So this is the steps I would take to actually solve the problem, okay? And what we want to do is we actually want to expand it and set everything equal to 0, right? We want to FOIL this, then bring this to the right side and have it all equal to 0. Why do we want to do that? Well, what we want to do is once we have the quadratic equation, we are going to find the discriminant, okay? And the discriminant will tell us what whether we have 0 solutions, 1 solution, or 2 solutions, okay? And the discriminant, I will show you in just a second, is very familiar to you, or it should be. So let's quickly FOIL this on the right. So we have 2x squared outer plus 18x inner minus 3x last minus 27 is equal to x minus 5 over 2. We're going to combine these to be 15x. Okay, and then we're going to multiply everything by 2 because we want to get rid of this denominator. So we're going to multiply all of this by 2. And so if you're following along, this is 4x squared and then 15x times 2 plus 30x minus 27 times 2 is 54. And that's equal to x minus 5. And now we're going to subtract x and add 5 to both sides, right? We want to do the opposite because we want to get minus x and plus 5 because we want to set this equal to 0. So 4x squared plus 29x. Minus 54 plus 5 is minus 49, I want to say. Yeah. And so now we want to find out the discriminant. The discriminant. Okay? And that's going to be equal to b squared minus 4ac. And you recognize this because we find this in the quadratic formula. Okay? So if we can find out what the discriminant form is, then it will tell us whether or not we have 0 solutions, 1 solutions, or 2 solutions. So b squared minus 4ac. So b is 29, so it's going to be 29 squared minus 4 times 4 times negative 49. And so actually we don't have to do much more than this, because all we have to know is if the discriminant is less than 0, equal to 0, or greater than 0. Okay, and if the discriminant is greater than 0, which is the case here, okay, you don't need to do anything because we see that minus is plus, so this will definitely be positive. If your discriminant is greater than 0, then you have 2 solutions. If your discriminant is equal to 0, okay, if it's equal to 0, then you have 1 solution, and if it's less than 0, then you have 0 real solutions. Okay? So I urge you to look up this discriminant form and see how it will help you find out how many different roots you have of your equation. And if you have any questions, let me know in the chat. Okay. And if you have a faster way of doing this, also let me know. I know that a few of you comment on some faster methods, and I really appreciate that. So keep that coming. Do not be shy. Make me look stupid. It's totally fine. Yes, let's continue. Number 12. Ken and Paul each ordered a sandwich at a restaurant. The price of Ken's sandwich was X dollars. The price of Paul's sandwich was $1 more than Ken's. If Ken and Paul split the cost of the sandwiches evenly and each paid a 20% tip, which of the following expressions represent the amounts of dollars each of them paid? So there are 2 main ways, again, to solve this. Either solve it algebraically, which is fun, and I kind of like this problem algebraically, or choose your own numbers. And that could be a lot faster and kind of more practical for most students. So maybe I'll try that method. Let's say that Ken's sandwich is $10. You can pick any amount you want. Okay? I'm going to say $10. Okay, so Ken's sandwich is $10. Paul's sandwich is $1 more than that. So his cost 11. So if they split the cost of the sandwiches evenly and each paid a 20% tip, okay, they split the cost of the sandwich evenly and paid a 20% tip. Okay, so they basically split the cost. So if we combine this, right, together it's $21. Okay, they paid a 20% tip. What is 20% of $21? Well, 20% of $21 is 21 times 0.2. Okay, and 21 times 0.2 is $4.20. Okay, so now together everything is $25.20. Now if we divide it by 2, because they're asking us how much each of them pay, we see that each of them pay, so that would be $12. Okay, and below one, $12.60. So I just went all this way to get $12.60, but $12.60 is not any of our answer choices, right? How do we figure out which of these is equal to $12.60? Well, we know that X in our practice example, right, in the example that we made up, is 10. So actually we can use 10 in each of these, right? So let's see how that works. If I plug in 10 for this X right here, 0.2 times 10 is 2 plus 0.2, right? That does not equal 1260. We're looking for 1260. So A is not correct. B, 10 times 0.5 is 5 plus 0.1, that's not 1260. Now 1.2 times 10 is 12 plus 0.6 is equal to 1260. Okay, so C is our correct answer, right? And we did not need to do any algebra in this problem. All I did was I chose a number and I stuck with that number throughout the entire problem, even when I checked it with the answers. So this is kind of the key right here. Just choose a good number. It could be 10, it could be 100, it could be 1, whatever kind of makes sense for the problem, and stick with that number throughout the entire course of your solution. All right, so that's pretty fun. If you want to see the algebraic method, they probably will have it in the back of the book. That's usually the method that the test makers opt for, so you can check that out. Okay, the function f and g defined by f of x is equal to this and g of x equal to that. Okay, the above graphs. Okay, intersect the points k0. Gotcha. What is the value of k? Okay, this makes sense. So really all we have to see here, because we know that k is x, right? This is the x coordinate, or sorry, this is the x-axis and this is the x coordinate. So k is kind of like our x in this problem. They're basically saying, what does x have to equal to so that y is 0, right? Which one of these, if k is one of these, will y equal to 0? And it's actually will equal 0 in both equations, right? Because they both kind of go through k0 and negative k0. So that's pretty easy, right? All we have to do is try out each of these, plug this in for x, and see which one of these equals to 0. And so let me try a. 1/4 squared minus 2. So 1/4 squared is 1/16. So that's not it, right? Minus 2. So that would be 8/16 minus 2. No. 1/2 looks like it could be the answer. So if I do x times 1/2 squared, 1/2 squared is 1/4. 8 times 1/4 is equal to 2, and 2 minus 2 is equal to 0. So B is the correct answer. That's actually pretty easy for such a late problem, because remember, as they get later in the test, they will get more difficult, and if they're not getting more difficult, they'll probably get longer. Okay, so we might see that shortly. Number 14. If the expression above is rewritten in the form a plus bi, where a and b are real numbers, what is the value of a? Okay, so pretty much we have to simplify this complex fraction. And if you've worked with complex fractions before, you'll know that the way that you simplify the denominator is multiply it by the conjugate form, by the conjugate. So what is the conjugate of 3 minus 2a? So the conjugate is simply this same exact expression, just flipping the sign. So if my expression is 3 minus 2i, the conjugate will equal 3 plus 2i. It's just that simple. And so what we want to do now, I'm going to rewrite this here, is you want to multiply both the numerator and denominator, by the conjugate, 3 plus 2i. Okay, and notice that I'm multiplying. You might be thinking, okay, how can you just multiply by a random expression and just, do whatever you want? Doesn't that change the fraction at all? Well, actually, in this case, it does not, because we're multiplying by something over something, right? We have the same term in the numerator and denominator. And we know if you have anything over itself, that's going to be equal to 1. Okay, so this actually is basically like multiplying the fraction by 1, which we know does not change it at all. So that's why this is a fair method and pretty much how you should be solving these problems. So how does this help us? Well, let's start in the denominator. What's 3 minus 2i times 3 plus 2i? The way that you would solve this is noticing that we have something called the difference of squares. Okay, if you have x minus b times x plus b, you can rewrite that as, right, so if you have something like this, x minus a times x plus a, you can rewrite it as x squared minus a squared. This is just a simple rule that you actually should write down on an index card and remember, okay? That this is called the difference of squares. And so now if we apply difference of squares, we see that in the denominator, we get 9 minus, okay, 2i squared. What is 2i squared? 2i squared is equal to 4 times I squared, and I squared is equal to -1. Okay, so that's basically like saying -4. Right, so now we have 9 minus -4, and so our denominator is going to be positive 13, right? But we'll get to that in a second. Now, let's deal with the numerator. 8 minus I times 3 plus 2i. We want to just solve this by using our favorite method, FOIL. Okay, so let's quickly FOIL. So we get first times first is 24. Outer is 8 times 2i plus 16i. Inner minus I times 3 is minus 3i. Last is -I times positive 2i, which is -2i squared, which is plus 2, I think. Yes. And so now if we simplify everything, let's combine all of our like terms, we see that we get 24 plus 2, so we get 26. 16i minus 3i is 13i over 13. Whew, that took a while, but we're finally here at the end, and we've done this already 2 or 3 times in just this one test, right? If we have a single digit in the denominator, we can divide each of these numerator terms by it. So 26 divided by 13 is equal to 2. 13i divided by 13 is equal to 1i. So 2 plus I is the correct answer. And so they're asking us, what is A, right? In the form A plus BI, A is going to be 2. Woo, that was fun. So what you just saw here is a problem that I guess it could be considered hard if you have not worked with complex problems or complex fractions, but it really, if you have worked with them, it's still kind of annoying because it's long, right? Like I don't see that like a really significantly faster way to do this than what I just did. You know, you could maybe shorten some things in your head, but overall it's going to take a while. So what this tells me is that if I was in this test right now, I would probably skip it knowing how long it's going to take. I would skip it, maybe go to 15, try that one out. And I see that this is basically the end of the multiple choice part. So if it was me, I would skip 14 and 15, go straight to the short answer. The problems should get easy again, okay? I would get through as many of these as I can. Once these get a little bit too hard, I would go back to the multiple choice again, okay? So you just want to make sure that you're optimizing your speed by doing the fastest problems you can when you can. Oops, am I all good here? My PDF is not happy. I was switching too quickly, too fast. Okay, we're back. Okay. All right, and remember, by no means ever in the world do you leave anything blank. Circle something. You do not get any points off for getting wrong answers, so please do not leave any multiple choice question blank. Just circle a random letter if you're like desperate on time. Okay. So, coming back. In the quadratic equation above, k and p are constants. What are the solutions for x? Okay, and if this form is not familiar to you, go back to your books, pick up the quadratic formula, memorize it, put it on an index card, and memorize it again, because you will see it a lot. So this is clearly the quadratic formula at play. So how do we get our A, B, and C for the quadratic formula? Well, first of all, we want to set everything equal to 0. So I'm going to subtract 2p on both sides, because we want to set everything equal to 0. So if I rewrite this, x squared minus k over 2x minus 2p is equal to 0. And so now A is equal to 1. Okay, it's 1x squared. 1. B is equal to negative k over 2. Okay, that's the term that's next to the x. and c is equal to this entire negative 2p, right? Because we know that p is a constant, so it's included in this. So that's what a, b, and c are. So now all we have to do is negative b plus or minus the square root of b squared minus 4ac, also known as the discriminant, all over 2a. So let's fill this out quickly. K over 2 plus or minus the square root of b squared. So negative k over 2 squared is k squared over 4, positive, right? Because negative times negative is positive. Minus 4 times 1. I won't even write that, right? Because 1 times anything is just itself. 4 times 1, fine, I will write it. Negative 4ac times negative 2p. Okay. That's a 2. All over 2 times 1, which is just 2. So, let's do this. K over 2 plus or minus the square root of 4 times negative 2p. So it's going to be k squared over 4 minus, plus 8p. Right? Are we on the same page? Wait, minus 4ac. Okay. Why am I freaking out here? Minus 2p. Okay. I see what's going on. Okay. Minus 8p all over 2. Woo! Okay, so which of these is equivalent? Now that we have this figured out, it's pretty tricky here, right? Very easy to go wrong. And so what we can do, right, is again split these up. This is already the 4th time we're doing this. The 4th time. All right, we're going to split up these two into 2 separate fractions. So it's going to be k over 2 over 2 plus or minus, and the square root right here. K squared over 4. K squared over 4. Oh, I kind of like the zoomed in here. It's pretty nice. K squared over 4. Actually, I'm not going to write this here. Sorry. I'm going to write this here. K. What's going on? What's going on here? Okay. Over 2 plus or minus the square root of... I don't know why I'm having so much trouble typing. Not even pressing anything. It has a mind of its own. Look at this. No hands. Ah. Please stop. I don't know what I did to hurt you. All right. Are we friends? Are we friends yet? Oh my God, no, we're not. No, we're not. This is crazy. Okay, I think we're back. That was scary. That was actually a little frightening. But we're back. K squared over 4. Plus 8p over 2. Okay, so k over 2 over 2. All right, we're dividing this by 2, so this is actually going to equal k over 4. So right away, I think we can cross out something here. We can cross out this one and this one. Okay, so now all we have to do is figure out which one of these this is equal to. And so we see here that if we divide each of these by 2, okay, this is inside of a square root symbol. So we're actually entering a 2 inside of a square root symbol. And if that's the case, right, if you're taking an outside digit and bring it inside of a square root, you actually have to square it, okay? So when I divide these inside the square root, I'm not dividing by 2, I'm actually dividing by 4. Okay, I'm dividing by 4. So this gets divided by 4 as well. This is divided by 4, and that's divided by 4. And so we see that in the end, our answer here is, I believe, A. Okay? Because we have 8p divided by 4. Yeah, oh, actually, okay, I see, I'm sorry. I see what they did. They actually brought out, so, okay. Sorry. So what they did, actually, is they brought out the 4 from each of these. They actually divided the 4 from each of these and brought it out here. And so it's the opposite. If you take a number from inside and bring it outside, then you actually have to square root it. Right? You see how that goes? If you take a number from outside of a square root and bring it in, okay, you have to square it. So you have to square it. If you're taking it outside of a square root, then you have to square root it. So if we're dividing 4 and we're bringing it outside of a square root, okay, we square it to make it a 2. And so that's why we're going to divide it by this right here, and it will equal A, as we said earlier. Okay, so that was a really long problem, and maybe I'm going to go back and kind of cut some of these parts out, like when the computer's freaking out on me and I couldn't control it. That was really scary. So I might edit that out. But listen, this is the excitement of live streaming. Okay, you get some crazy experiences like that. So forgive me if that went on a little bit too long. I will try to shorten it in the near future. All right, 16. Jim has a triangular shelf system that attaches to the total height of the system is 18 inches. There are 3 parallel shelves. Okay. Okay. So I see here that there are 3. There are 3 parallel shelves, and so it actually tells me that these are all similar triangles, right? This is the small similar triangle here. This is the medium, and this is the large. Okay, so those are the 3 similar triangles. So they're basically saying that the proportion, the entire thing. So this is x to 3x to 2x. What we can do is that we can combine this and say that this entire thing is equal to x plus 3x plus 2x, which is 6x. Okay, so that's the proportion. And we know that 6x, that whatever the proportion is, it doesn't matter if it's for the side or for the height, the proportion will still be the same. Okay, so what I mean by that is that this to this will still be 2x to 3x, okay? Even though what they told us was this to this. The proportion will still be the same even for the height, okay? So if that's the case, then we know that it's still going to be 3x, 3 to this entire thing, right? So it's going to be 3x to 6x. Right? So it's going to be 3 to 6, aka 3 to 6, aka 1/2. Okay, so this middle height will be 1/2 of the entire height because this is 1/2 of this. Okay, so the proportions, they still remain the same even for the height. And so if that's the case, then we know that this must be half of the entire height. 18 divided by 2 is 9 inches for that height. Okay. Triangle above, sine of x is 0.6. What is the cosine of y? So actually the sine of x and the cosine of y are the same thing. So how do I know? Well, we know that sine, so ka toa. Sine of x is equal to the opposite, so it's the opposite, over the hypotenuse, O over h. Whereas cosine of y is going to be equal to the adjacent, which is the same side here, right? This is adjacent to y, and this is opposite of x. So it's going to be actually equal to adjacent over hypotenuse. But since this side is the same, the cosine of y will also be 0.6. And I've actually seen these problems a lot, especially in these past couple of practice tests. So be familiar with the whole concept of sine, cosine, and the fact that the sine of the sine of one of the angles and the cosine of the other are actually the same thing. Like that one single concept actually does come up a lot, surprisingly. Okay, for what real value of x is the equation above true? Ooh, this is a good one. So you kind of have to factor this. A guess and check will be pretty hard for this. So you kind of have to factor it. And regular factoring methods probably will not work. So when I mean regular factoring methods, I mean something like FOIL, something like quadratic equations, right? Because this is actually a cubic function. I just missed that completely. So we have to find something new. And I would say usually at the SAT level, they're not going to ask you any sort of like higher level factoring methods. They're going to have you stick with the basics. And so if you see something with a cubic function that you can't really factor, what I want you to start looking for is a grouping. Can you group these polynomials, or can you group these terms so that you'll somehow get a common factor out of them? Okay, and I'll show you the grouping that I see here. So if I group x cubed and 2x, and I group negative 5x squared and 10. So I'm going to rewrite these. I'm going to say x cubed plus 2x minus 5x squared minus 10. So why did I pick these two groupings? So I'm going to factor this group first. And the way I'm going to factor that is I'm going to factor out an x. I see they both share an x. So if I factor out an x, I get x times x squared plus 2. Okay, I just removed an x from each of these. And now in this grouping, what do they both share? They share negative 5, right? So I'm going to actually factor out negative 5. So what's negative 5x divided by negative 5? That's just positive x squared. And then minus 10 divided by negative 5 is positive 2. So do you see why I chose these groups? Because now inside of the parentheses, we have the same exact binomial. We have x squared plus 2. So what's cool about that is I can actually factor out x squared plus 2 from each of these. So I see I could factor out x squared plus 2, and I have x left there. And if I factor out x squared plus 2, I have a minus 5 left there. So do you see how we took this giant, mean-looking cubic function and we turned it into kind of a simple multiplication, parentheses, something that we're used to. So this is equal to 0. And so for what real value of the x, for what real value is the equation above true? So basically each of these, right, each of these could be equal to 0, because if either of these two parentheses are equal to 0, then the entire function will be equal to 0. Right, you see that? If this is equal to 0, this times this will be 0. So I see that x minus 5 is equal to 0, and x could be 5. All right, so in this case, x is equal to 5. What about in this case? X squared plus 2 is equal to 0? Well, actually now if I start solving for x, minus 2, I see that x squared is equal to negative 2. So this will not produce a real value. It'll be an imaginary number, right? Because we're finding out the square root of a negative. So in our case, the only real value is 5. Boom. How many more we got? 2 more? That's it? Okay. Let's do it. Oh no, my flux is turning on. Let me turn that off for just a second. It's getting dark out. Flux, disable. One second here. I wonder if you guys can see my screen. Is it probably, no, it probably doesn't flux on your side. All right, and this light actually kind of covered up a little bit, so it's not as blinding for me, thankfully. Okay, so let's do this. Let's finish this up. If xy is the solution to these system equations, what is the value of x? Okay, so simple system of equations problem. In this case, I'm going to use elimination. We haven't done that yet, and this is actually a perfect problem for elimination. So to eliminate, we want to have either the y's or the x's cancel out when you add up the two equations, kind of like a sandwich. So we see that in this case, none of them will cancel out. But I see negative 3x and 6x, those are pretty close to canceling each other out. All I really have to do is multiply this by 2, and then negative 6 and positive 6 will cancel out. So let me do that. Let me multiply this entire top equation by 2. Okay, and you're allowed to do that. As long as you do it to both sides, it does not change that equation at all. So this is a perfectly legitimate strategy. You can multiply it by anything you want. So now I'm going to do negative 6x plus 4y is equal, sorry, what? Negative 6x plus 8y is equal to 40, okay? And so now let me stack up these two equations. Negative 6x plus 8y is equal to 40, and 6x plus 3y is equal to 15. So now I'm going to add up these two equations. And now I see that 6x and minus 6x cancel out. We have 11y is equal to 40 minus 15 is 25. Oh, they're not going to make this easy on us, huh? So now we're going to divide both sides by 11. And we're going to get y is equal to 25 over 11. Okay, so I hope I didn't make any mistakes here, because they don't usually give us kind of these tricky fractions. Did I do everything correctly? Just gotta trust myself. Wait a minute, I didn't. This is minus 15. It's supposed to be equals 15, not minus 15. I'm a knucklehead, sorry. So this was supposed to be 40 plus 15. So this is supposed to be 55. And so y is equal to 55 divided by 11, so y is equal to 5. Yeah, the SATs don't make it too hard on you. So they didn't ask us for x, or sorry, they didn't ask us for y, they asked us for x. So how do we use y to find out x? Well, we can actually plug in this value of y into either of these two equations. You'll get the same answer. So I'll plug it into the second one here. So let me rewrite this. 6x plus 3 times 5, right? Not 3 times y, 3 times 5 is equal to 15. Now 6x plus 15 is equal to 15. Wait a minute. 6x, I'm going to subtract 15 here, minus 15. 6x is equal to 0, so x is equal to 0. That was pretty tricky. That's about it. All right, last one. Numero 20. The mesosphere is the layer of Earth's atmosphere between 50 and 85 kilometers above Earth's surface. At a distance of 50 from the Earth's surface, temperature is -5, and distance of 80, temperature is -80. Okay. For additional 10, what is? Oh, okay. So they're basically asking us for the rate of change, right? They're saying for every additional 10 kilometers, it decreases by k degrees. So that's kind of a rate of change problem. And rate of change we also know as slope. So this is very similar to what we did in that other problem with the training, where it was weeks of running and how many miles, something like that. So it's a very similar problem, right? Except in this case, it says that this is the kilometers, this is the temp, and we see that 50, actually it's not a good drawing. I'll just say that this is a negative axis. So at 50 it's -5, and at this is positive 50, and at 80 it's -80. So it's here and here. And so we just have to find out what is the slope. So we can actually maybe rewrite these as two ordered pairs. That'll make it easier for us to visualize. So the first ordered pair is 50, -5. And the second ordered pair is 80, -80. So how do you find the slope between two ordered pairs? Well, the way we do that, same thing as always, difference of y's divided by difference of x's. Okay, so what is the difference of the y's? So we'll do -80 minus -5 over 80 minus 50. And so -80 minus -5 is -80 plus 5, which is -75, over 80 minus 50, which is 30. Okay, did I make any other silly mistakes, as I tend to do? 50 -5, 80. Okay, so I think I'm good here. So we know that for every degree, or sorry, for every additional meter, right, because we're doing this for every kilometer, it decreases by 75 over 30. But I just noticed that they actually didn't ask us for every additional kilometer. They said every additional 10 kilometers. So that means that we have to take -75 over 30 and multiply that by 10. So that gets us -750 over 30. And we could get the zeros out of there. So that's equal to -75 over 3. And so, oh, actually, 3 goes into 75, right? So -75, so 3 goes into 75. 3 goes into 7 2 times. 1 is left over. Oh, 25. So that's equal to -25. Boom. Very nice. Ooh, oh, they almost got us. Almost. I knew there was one more little trick. They say that it decreases by k degrees Celsius, right? So it decreases not by -25, it decreases by +25, right? Because we know that every 10 kilometers it goes down by 25, but that's like saying it decreases by +25. Man, these SAT guys, they're tricky. They're a little tricky. So that concludes section 3 of practice test 4 of the College Board Blue Book. If you haven't yet seen it, there is a link to the PDFs. They're all free, all officially licensed by the College Board online, and that's in the description. Lastly, if you want to subscribe, you do not have to. It would be really nice of you. The goal is 20 subscribers. Yeah, by the end of the summer, hopefully. Then I will be doing surprise subscriber sessions, and that will be completely unannounced. The only way you will find out about them is by getting a subscriber notification, and these will be surprise sessions where I will probably have a much smaller audience, and we can kind of talk one-on-one, and you can pretty much ask any math or biology or chemistry question. Those are kind of my go-to expertises, if that's even a word. So apparently language arts is not one of my expertises. Okay, I'm going to stop there before this gets any worse. So thank you for joining me, and I will see you on Thursday.